And this one goes with de Broglie equation. It says, dual behavior of matter proposed by de Broglie led to the discovery of electron microscope, often used for highly magnified images of biological molecules and other types of materials. Loving though this is, it's all junk. This is one piece of question which is just irrelevant. If the velocity of electron is so much, I'm given velocity of electron as 1.6 into 10 raised to 6 meters per second. Calculate the de Broglie wavelength lambda associated with this. Lambda is h by p, h by mv. Oh my God. Very often electrons are used. So let me just see, this is 6.626 into 10 raised to minus 34 joule seconds divided by 9.1 into 10 raised to minus 31 kilograms into velocity. Just for the sake of convenience, let us say if the velocity was 10 raised to 6 meters per second. That's a lie. I know it's a lie. It is 1.6 times. We'll see that. We'll handle that. Just stay with me. I just want to calculate a shortcut for you so that each time you're not harassed with these calculations. These calculations come across you very often. Let me divide them and get you a number. First of all, 34, that is 10 minus 3, 10 minus 6, that makes it 6.626 by 9.1, loving though this is, and this into 10 raised to minus 9. Yeah, 0.91 if I take this into 10 raised to minus 8 meters. Right? This is a number which I tend to get by, you could say, some number V0. What is V0? V0 is velocity upon 10 raised to 6. I've used already 10 raised to 6 because roughly this is the range or the order of magnitude for which you will normally encounter the velocity of electron. I just divide this and let you know the number. This, if you see, this is 728. Yeah, 7.28 into 10 raised to minus 8 upon V0 meters. If you find this ugly, I would suggest that 10 raised to minus, just convert it to 10 raised to minus 9, so you will have nanometers, right? So that would be 0.728 upon V0 nanometers. This should be your answer. Now, in our case, V0 is 1.6. So our answer, if you want to use this as general formula for de Broglie wavelength of electrons, you can save some bit of calculation. If you are confused, let me repeat. Very often, de Broglie wavelength of electrons is expected. Mass of electron is fixed, Planck's constant is fixed. So I am suggesting that de Broglie wavelength of electron, you just remember with calculation, this is 0.728 nanometers by V0. And what is V0? V0 is velocity of electron upon 10 to the power 6. Usually when you are encountering such electrons, they often have velocities in terms of 10 raised to 6 meters per second. SI units, of course. You take them, you substitute this, and without having to do all these calculations, you will directly get the answer. If you have energy to remember it, mark it up. In our case, the answer would be just 0.728 divided by 1.6 nanometers. How much does that come out to be? 16 4s are 64. So 16 4s are 64. Sorry, this will be 0.4. Then 72, that means 88. 16 5s are 80. 0.455 electron. See, 0.455 nanometer. So, even less than a nanometer, the de Broglie wavelength associated with this electron is 0.455 nanometers, or if you want picometers, 455 multiplied by 1000, 455 picometers. Very small.